We're going to begin our lesson here, which deals with number sets, and these you're pretty familiar with. We have basically our real numbers, which is what most of our class is going to be dealing with, is all real numbers. But we do have some things that we're going to be concerned about a little bit later, which are imaginary numbers. And imaginary numbers are kind of strange things, like the square root of negative numbers, like the square root of a -4, or the square root of -7. They're not real, but real numbers are what we're going to be working with. So in our real number system, the first thing that you probably learned way back when you first started working with numbers is how to count. You know, as children, we learned to count 1, 2, 3, and so on. Those are the natural numbers. And once we got a little older and talked about subtraction, like 3, take away 3, what's left, we added to that a very special number, which was 0. So now we're looking at the set of all whole numbers when we include the natural plus 0. And then we build on that set and considered negative values, which are also this 1, 2, 3 counting numbers, except they're negative, and that forms this set of numbers, which are the integers. Now, within the real number set, we have two major categories, rational and irrational. And rational is just simply a ratio of two integers, like a fraction of two integers. So something like 5/9, that's pretty easy to see that that's a rational number. You can write it as a ratio of two integers. Even 1.6 repeating, that's a rational number because 0.6 repeating is 2/3, and 1 2/3 is 5/3. So 5/3, 5 divided by 3, is a ratio of two integers. So anything that can be expressed as a ratio of two integers is rational. Sometimes people like to think of, well, instead of worrying about the rational, think about the weird stuff, like the irrational. So irrational numbers are things like this that we have up here in the top. This, let's see what we call it, pi, square root of 3, square root of 5, things that you can't find the square root of. Now, the square root of 25, you could find that value, which is 5, so that becomes rational. So weird things like this are irrational, and our other numbers are not weird. Those would be considered our rational numbers, a ratio of two integers. Also, with these numbers, these ratio of two integers, we want to consider where they lie on the number line. And now notice this is a real number line, so we don't have any imaginary numbers on this at all. These are all real numbers. So real numbers can be things like pi, which is irrational, or it can be 1.7, which is rational. Those are positive values, so they're to the right of 0. And 0 has a special name. It's called the origin, as we look at the number line. And these numbers that lie here to the left, that are decreasing, those are negative in value. And here again, they could be rational or irrational on our number line. Now, let's see. I need to exit this. I'm trying to learn how to do this with the... Hold on just a second. Okay. And in addition to this, in section 1, we also are looking at the term absolute value. Now, absolute value is these bars that are given here, like the absolute value of a -7. Well, absolute value is basically the distance from the origin. So how far is the number -7 from the origin, from 0? And as we look at those spaces there, we can count, very quickly count, that that's 7 units away. So the absolute value of -7 is 7, the distance. And the same thing's true for the absolute value of 6. It's 6 units away from the origin. So it's just equal to 6. Well, when we consider comparing these numbers on the number line, we're going to be using symbols such as greater than. That's the one that opens to the right. That's a greater than symbol, and a less than symbol. And as in this expression right here, when we look at these two numbers, -4 and a +2, and we're comparing those, we could say this statement that 2 is greater than negative 4, because 2 is to the right of negative 4. Or we could just as easily have said negative 4 is less than 2. Notice that the arrow for that inequality points to the smaller number. And another term that's used is a reciprocal. Now, every number that we're looking at in our real number system has a reciprocal except 0. You can't take a reciprocal of 0. A reciprocal is 1 divided by the number. So, for example, if we had something like 5, the reciprocal of that would be 1 divided by 5. 1 divided by that number. These two are reciprocals of each other. And when we consider in algebra our number system, we look at things called variables and constants. And variables are just literal numbers that vary in a given problem. And a literal number is just a number represented by a letter. Represent numbers by letters. So that's going to be a variable. And if that literal number's held fixed, then we call it a constant.